Today I shall discuss about Perkin condensation reaction or Perkin reaction. This is one type of condensation reaction. Here the starting material is taken as aromatic aldehyde and acetic anhydride, that is anhydride of a carboxylic salt is taken, and sodium salt of carboxylic acid is also added. The final product is cinnamic acid. If we take salicylaldehyde as the starting material, or as it is aromatic aldehyde, then we obtain coumarin as the product of the reaction. This is the structure of coumarin. And this is the structure of cinnamic acid. Cinnamic acid. In this reaction, aromatic aldehyde is taken as starting material or reactant, and acetic anhydride and sodium acetate is taken as reagent, and the final product is alpha beta unsaturated acid. Alpha beta unsaturated acid. Particular in this case, the acid is cinnamic acid. If we start the reaction with salicylaldehyde, this is the benzaldehyde, salicylaldehyde, and the reagent will be same in the previous case. The product will be coumarin. And now I shall discuss about the mechanism of the reaction. Mechanism of the reaction. Mechanism is the logistic pathway by which a reactant changes gradually to form the corresponding product. At first, the sodium salt of carboxylic acid ionizes to produce the corresponding anion. Then the anion attacks to the sodium salt of carboxylic acid to produce the corresponding acid anhydride ion. CH3 COOH plus CH2 minus COO CH3. These species undergo this type of resonance. It must be shown which happens during the course of reaction. Again, the anion formed reacts in the next step to the corresponding aromatic aldehyde, that is benzaldehyde, to form the next intermediate compound. This anion attacks to the electrophilic center, and the pi bond goes to the O atom, and this is formed CO minus H CH2 CO O CO CH3. Under this condition, H2O molecule attacks to the corresponding carboxylic group and the leaving group departs from the species to produce pH, CH, OH, CH2, C, double O, H. This is the beta hydroxy carboxylic acid. We know that when beta hydroxy carboxylic acid, beta hydroxy ester, beta hydroxy carbonyl compounds are heated, one molecule of water is eliminated to form the corresponding alpha beta unsaturated compound. When this is heated, one molecule of H2O is eliminated and pH, CH, double bond CH, C double OH, that is cinnamic acid, is produced. Cinnamic acid is produced. This is the whole mechanism of formation of cinnamic acid, starting with benzaldehyde. Mechanism is nothing but the logistic pathway by which a reactant changes step by step to produce the corresponding product. Now I can show the mechanistic pathway of the second reaction, that is when salicylaldehyde reacts with the sodium acetate and acetic anhydride to produce the corresponding coumarin. Similarly, in the first step, acetate ion is produced from sodium acetate and then H atom of sodium acetate attacks to the acetic anhydride to produce the corresponding anion CH3 COOH plus CH2 minus COO CO CH3. Then the anion produced undergo resonance. It must be shown CO minus O CO CH3. Then this anion attached to the carbon of salicylaldehyde to produce the intermediate compound. CHO minus hyphen CH2 CO O CO CH3 OH. Then water molecule attacks to the carbonyl carbon and the leaving group departs to its initial position. CH2 COOH. Again we know that this is the beta hydroxy carboxylic acid. When beta hydroxy carboxylic acid is heated, one molecule of water is eliminated from the alpha and beta position to produce the corresponding alpha beta unsaturated carboxylic acids. And when we also heat here, particular in this case, two molecules of waters are eliminated, one from alpha beta position and another from carboxylic acid and this OH group. So coumarin, a cyclic compound, is produced like that. This is the coumarin. This can be treated as alpha beta unsaturated cyclic ester. Alpha beta unsaturated cyclic ester. This is coumarin. Similarly, other aromatic aldehydes respond to this test, Perkin condensation reaction. Today's discussion is up to this. Thanks to all.